All right, welcome back, ladies and germs. Okay, so here is what we have got for the next problem. Okay, so we are in section 2.1, and I'm going to do one problem just right out of the homework. There's just not a lot of problems here. So, satellite dish is a precise mathematical shape, a parabola, because that's what we're doing in chapter 2. We're talking about parabolas. So, parabolas are shapes that do this. So they, in other words, they open down or they open up. Okay. Now this, this satellite dish is going to open up. Now, sometimes, like the satellite dish, it's kind of a wide thing there, but that is, it can be very narrow as well. Okay. So, anyway, so it says the scale drawing of a cross section of a 28-foot wide parabolic satellite dish is shown on the graph where each square is 1 foot by 1 foot. Okay. And so this right here tells us that each block, okay, that's 1 foot and that's 1 foot. And so horizontally, that's how that works. And vertically, that's 1 foot, that's 1 foot, and so on. Okay. So it gives us an idea of, okay, what does it all mean? But also it tells us the um, that the units for the x units and y units are both feet. Okay. Um, you know, Sometimes one's going to be ounces and one's dollars. Usually they're not the same units, but here they are. Now the dish is designed using the following equation. Okay. So so how far do you go up in the y direction? Well, that's determined by your x direction squared multiplied by 0.04, and then add 2 to it. Okay, so the ordered pair solutions of the equations become the dimensions necessary to build this amazing device. All right, so part A, treat the x-axis as the ground. All right, and use the equation to find the height of the dish above the ground at the 2 foot intervals shown on the graph. So this is the ground, and so down here below the x-axis, you can ignore that because that's under the ground, and we're not going to go there. We're not, digging graves or anything. Um, and they say at 2 foot intervals shown on the graph. Well, you'll notice that horizontally, this point and this point are 2 feet apart. Okay, 1 foot, 2 foot. By the same token, you could say this one and this one are 1 foot, 2 feet apart. Okay, so horizontally, things are 2 feet apart, each consecutive pair of points. All right, so treat the x-axis as the ground, use the equation to find the height of the dish above the ground at each of those. All right, so you can have the calculator do this in a really easy way, um, but that requires me showing you some other stuff. Showing you the input output table. I'm not going to do that. Anyway, let's start with this point here, and then we'll just kind of work our way from to the right. Now, what's the x coordinate of this point here? Well, let's see. We go to -4, -6, -8, -10, -12, -14. All right, so -14, that's going to be the first one. So that's the x value for that one. Okay, now we can get a pretty darn good idea of what the y value is. I mean, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's pretty close to 10 when x is -14. Okay, well, we can get the exact answer, and let's take a look. Okay, so the equation was 0.4 times whatever your x coordinate is, which in this case was -14, and then plus 2. Okay, whoa, that does not work. Let's see, what do we got? Oh, 0.04. I was gonna say we should end up with about 10. Um, okay, let's try that again. All right, and I might be in a silly mood. I just watched an episode of Psych. Um, it was the John Hughes episode from season 3. Okay. Um, oh, and I forgot to square it. I'm supposed to square something. I'm supposed to square the x. Oh my gosh. Okay, this is why it's good to look at the graph. Okay, so that when you make a mistake, like I'm doing over and over, it wasn't on purpose, then you have a pretty good idea. There we go. Now we've got something that makes more sense. That's close to 10 feet off the ground. Okay, so when x is negative 14, y is 9.84 feet. Okay, I'm going to arrow up, highlight that, hit enter, and then I'll just say, okay, so the next point on the graph was when x is negative 12. Okay, and so I can just say, boom, like that, 7.76 feet. That'll be the y coordinate that goes with that one. And then um, and then you can arrow up and you can say, all right, the next one was, because again, they're 2 feet apart. So the next one is going to be 10 feet to the left and 6 feet high. So when you're 10 feet to the left of the center of the satellite dish, you're 6 feet up. And then you just keep going until you get to the last point on the parabola. Now you'll notice that as you look at as you find the y coordinates of these guys over here on the right, it's going to be the exact same ones as the one on the left because parabolas are symmetric. Okay, but you can still plug them all in. Okay, anyway, that'll give you the answers to A. Now, B says, recall that the quadratic equation y equals ax squared plus bx plus c defines the geometric parabola. This is just kind of your general equation for parabolas. So it turns out that the focus point is located a distance 1 over 4a above the bottom of the dish. Find this distance for this satellite dish. Okay, this does pop up in the homework just a little, not a lot. We're not making a big deal out of it, but I did want to include. Okay, so here in my video. So basically, they're saying go find 1 over 4a. Okay, well, there's 1 over 4, and then times, and then I got to multiply that by a, 4 times a. Well, a is the number that's multiplied by x squared. Well, in our equation, the number multiplied by x squared is 0.04. That's our a. Okay, and then, I'm just gonna do say alpha y equals enter because it's cool, and then I'll type this in for times 0.04. Okay, and so 6.25, what does it mean? That means that, so 1 over 4a, that tells you how far above the center point called the vertex, how far above the focus of the parabola is. So it's up 1, 2, 3, 4, 5, 6, and a quarter. So right there. Right there at my dot, that's going to be the focus of the parabola. You can think of the focus as like when you're a kid and you got a magnifying glass and you're trying to burn ants and stuff, and so you move the magnifying glass up and down until you get that beam as tight as you can. And when you get that beam as tight as you can, the distance from the magnifying glass to the ant that you're burning, that distance is that 1 over 4a, that focus distance. Okay. Anyway, I'm glad we get out on a positive.